Good afternoon everyone, I am Jeevan Sharma from Faculty of Civil Engineering and today I am going to present you a short presentation on my current research, which is also a part of Engineering H51 in research method, and my subject is Wastage Fill Material Socio-Economic Benefits. What is waste? I hope every of you are familiar with waste and you well know the meaning of waste. And looking at these pictures in the slides, I think, while remembering about waste, I think one word will go in each of your mind, and it must be no other than yuck. Alright, and waste is something that is eliminated and discarded after its primary use, and by definition of United Nations Environment Program Basel Convention, waste are substances or objects that are disposed of or are intended to be disposed of or are required to be disposed of by the provision of national law. And about waste generation, I am going to talk about the two major waste contributors. One of is domestic and another industrial sector. Domestic waste contribute around 37% of total waste, and industrial waste contribute around 29% of total waste. As we all know, domestic waste are bottles, cans, clothing, compost, food waste, food packaging, newspapers, magazines, and yard trimmings. And industrial waste are divided into two categories, that is manufacturing industries and construction industries. Manufacturing industries waste are the industry byproducts, and for example, the coal factory waste are fly ash, coal slag, bottom ash, etc. And construction industries waste are the demolition waste like aggregates, mortars, etc. And talking about the waste management, according to Jeevan 2007 and Belgium 2006, the best strategies for management of waste are reduce, reuse, and recycle. As every one of us know, reducing the waste is the wisest way of management of waste, and it also has several social benefits. And reusing waste, of course, we know it is another best way of waste management. And recycling, it will save the cost of new material construction, and also it will help to reduce the human exploitation in natural resources. And landfill, while talking about the waste management, we can't ignore this term landfill, as it is the site for waste disposal. It can be some open area or some area that is excavated, and it is a traditional method and applied by almost all the countries worldwide, and it has been applied from quite a long time, and also it is a cost efficient way, because there is no other need than to collect the waste from industries and domestic sectors and transporting them to the landfill site. But it has also several disadvantages, like availability of space is already one of the concerns for landfill, and it will for sure be major concern in the future. And it has several social and environmental impact, as it can cause air pollution in the surrounding society. And some major European countries like Germany, Austria, Sweden, Denmark, Belgium, Netherlands, and Switzerland have already banned the disposal of wastes in landfill. The waste management system of those countries can only throw waste materials in landfill after treat them properly. And also the electronic appliances, they contain a long list of hazardous materials like mercury, arsenic, cadmium, lead, which is the major contributor of underground water pollution, and also it will make fertile soil infertile. And methane, we all are familiar with the methane gas, which is most likely to be created in the landfill site, which is one of the greenhouse gas, and is 21 times more potent than carbon dioxide for the ozone layer depletion. So, isn't it the time to think about the best possible alternative? And several researchers have done research in waste management things. Several experiments, laboratory experiments and inside tests are already being performed, and using waste as filler material has been currently introduced as one of the must and one of the best thing to manage waste, as the waste can be used in structural field by compacting waste materials and some other earthen materials, and also they can be used in backfill, as in filling the excavated trench and existing holes. Also, waste can be used as filler materials in construction. Waste can be used in replacement of cement and concrete in the construction industry. And about talking about the materials that can be used as filler materials, almost all the industrial byproducts, all the waste materials can be used as filler material, as the tire chips, scrap tires from rubber industries can be used as filler material in construction. Fly ash, coal ash, bioxygen slag can be used as filler material, and the glass waste can be used as fine concrete and coarse concrete, fine aggregates and coarse aggregates in concrete, and also they can be used as PCC, and also the steel industry waste can be used in PCC and binders in concrete. And as we all know that every research has the cost benefit analysis. There is the cost benefit analysis in using waste as filler material, as it has been known to reduce the consumption of natural resources, and it has also been one of the best effective method for stopping the human exploitation of natural resources. And some experiments shows that the land reclaimed by waste materials has better strength than the original ones. Also, the fly ash, bottom ash can be used as replacement of cement. Fly ash can be used as 100% replacement of cement, and bottom ash can be used as partial replacement cement. And also, some experiments shows that the use of glass in filler material can reduce the cost of construction by up to 2.8%. So, talking about the environmental concern, as using waste as filler material has seemed to have no negative impact in the environment, and also the fly ash, which has been considered as the toxic stress element in the nature, if used as filler material, then it will help to prevent pollution. Also, there will be no leachate problem if the waste are used as construction filler material, and also this method has better social impact. And as I have already said, that the filling waste using as filling material has no negative impact in environment. And also the civil construction waste, which if used as filler material, then helps to reduce proliferation of vector-borne disease and also better environment, and it has better environment aspect. And I have considered several research, and some of the research gaps there where as they had been done for short-term analysis, were done no long-term analysis, and some they were only performed on laboratory scale, and some are only controlled demonstrated projects, and availability of fill material in terms of long-term has not been mentioned in some other research, and also cost-benefit analysis and environment impact on long run has not been mentioned. And I'm going to do a research design which will include the availability of fill material, I will research about the availability of fill material not only in short term, not only in the current situation, but also in long run, and also cost benefit analysis of fill material versus virgin raw materials, and the short term and long term environmental impact of using waste as filler material. And the methodologies that will be constructing the small real land reclamation project, where we'll be constructing a real island using film materials, and where total waste materials will be around 60% of total materials, and these waste will be metallic, polymeric, industrial, and domestic. They are divided into 4 components. The total duration of the project will be 5 years, and their study will be done in different phases. And study, as I have said, study will be done in each phase, and the viability of its material, technical feasibility, and environmental concerns will be the major part of my research. And also we'll do stability analysis, is strength, weakness, opportunity, and threat analysis. There will be still some limitations in my project. There will be it will not cover all the waste types. I have already talked that only 4 waste types will be considered in the project, and it will not reflect the actual generalized scenario of all waste film materials, because as I have already mentioned that only 4 materials can't summarize as all the waste materials, and there will be a time constraint of just 5 years, and environmental issues after 5-year period will not be addressed. That's my project, and these are the references I used in my project. And I hope after experimental things and some other things, I will present my conclusion in next presentation. So that is all for today. Thank you for everyone for being here and supporting me in my research.